My name is Francesco Laio. I'm the head of DIATI, the department which is organizing these webinars. And I'm here only to chair this session. Why this 5+2 challenges? The origin was a report by the U.S. National Academy of Science, Engineering, and Medicine, which identified, after following some expert advice, the 5 grand challenges in environmental engineering. This pertain with the climate change, with the sustainable supply of food, water, and energy, and with the efficient and resilient cities, and a world without pollution and waste, and a way to promote decision and well-balanced decision and actions. These are the first 5 webinars that we will have. The very first one was yesterday by Peter Wadhams on climate change. The second is today by Stefania. And in the next 2 weeks, we will have these 3 seminars and other 2 on critical raw materials and energy transition, which in our opinion belong very well to these challenges for engineers for a greener future, and belong very well to the competencies and expertise that we have in our department, and that we can exploit in our academic paths. Today, the speaker is Stefania. Stefania Tamea is an associate professor at Politecnico, at DIATI, so at the same department I belong to. Stefania is an hydrologist, and she has spent most of her career working on the linkages between food production and water, and also related to international food trade and many other things that she will probably speak about in her presentation. She is an eminent scientist. She has an international profile with some 4 years spent abroad, mainly in Princeton University. And I think you are all very much curious to hear what she has to say about sustainable supply, food, water, and energy. So, Stefania, thanks a lot for being here. The floor is yours.
Thank you, Francesco. Thank you very much for the introduction. In this talk, I would like to introduce briefly and convince you about the things that environmental engineers can say, can study, and develop in order to promote a sustainable supply of food, water, and energy, briefly. I will start talking about natural resources, because natural resources are vital for human life. We as humans, we have an endowment, a set of resources that includes air, water, soil, and energy. And these resources may be renewable, but they are finite. And I think that this concept is well represented by the picture of our Earth, this wonderful picture that I like very much, the blue marble picture of the Earth seen from space that was taken by the Apollo mission while leaving the Earth towards the moon. And seeing the planet as a whole, as we see here, we can understand that our resources are finite. Our resources are all there. They can be renewed, they can change in form, in shape, in spatial distribution, but they are all there. And many human activities use such resources to improve the human standards of living. But this comes at a cost for the Earth's natural system. And usually, the use of such resources have created a friction between the human societies and the environment. Competing interests, competing uses generate friction. And this is why, one of the reasons why environmental engineers have came into place and emerged. The field was aimed at supporting both human and environmental needs, and with the aim of mitigating the adverse impact associated with the human activities. So the eternal debate is among exploitation versus conservation. This dynamics is well represented with this diagram sketched in the plot here that is called environmental Kuznets curve. This is a curve that has been introduced in economic studies that puts into relation the income per capita in a given country on the horizontal axis with some kind of pollution index per unit income, typically CO2 emissions or any other measure of environmental degradation. And the curve shows that low-income countries that are found to the left of this diagram are characterized by a pollution index that grows at larger rates than the income level. So the development of technology usually is less concerned about environment and more concerned about advancement of economy, advancements of results, of production, etc. But then, as time passes and hopefully as the country develops more and increases its wealth, at higher income level, the trend flattens and at some point also reverses. Why does it happen? Well, because the economic wealth generates a social concern about the environment and trigger the development of environmental regulation and higher efficiency and also reduced emissions during the industrial activity. And therefore, while we all hope to be on the right side of this diagram, the social concern for the environment is materialized into the concept of sustainability. Sustainability, which has been the objective of many studies, and in particular of a big introduction by the United Nations, which proposed a set of goals, sustainable development goals, that are intended to guide human activities and planning for the future in order to reach a more sustainable world. We are not going through all of them because I'm quite sure that you know all, if not most, if not all of them. But I just want to focus on those which are related to the topic of this presentation. Zero hunger is one of the objectives of the Sustainable Development Goals. Having clean water and sanitation for all, having an affordable and clean energy availability. These are main points for a sustainable world. Clearly, there are other also goals that are related to the previous ones. First of all is climate action, but also the responsible consumption and production, as well as no poverty, which should enable the approach to food, water, and energy by everyone on Earth. So having this wide spectrum of aspects of sustainability, I want now to focus on the sustainability related to natural resources. So a good definition of sustainability in this context is has been written there, is meeting the needs of the present generation without compromising the ability of future generations to meet their own needs. So we do not have to compromise the quality and the quantity of natural resources in order to guarantee their the presence and exploitability also by future generations. And what is the role of engineers in these goals? Well, I have tried to sketch them, and I have separated them in two parts. One is the understanding and one is the finding. We would like to understand how much resources we have the supply, the availability, how much resources we use and how much we need in case the two aspects do not meet, and how the availability and needs will change in the future. And while understanding these processes, we also hope to find solutions to meet availability and needs, and to find adaptation strategies that allows us to take advantage of an evolving situation. So now let's see more in detail. These concepts apply to the field of food, water, and energy supply. Starting from food. Food is mainly produced by agriculture, clearly, which includes cultivations and livestock farming, just to be precise. And it involves some resources. Some of them are natural, some are anthropic, so related to the human beings. Certainly, land is needed, water is needed, solar radiation, solar energy is needed, but also nutrients. Not necessarily soil, but nutrients, yes. As anthropic resources, we need labor, knowledge, and possibly technology. Historically, in fact, increase in food production required by growing population have been enabled by production bursts driven by technological innovation, like food processing or farming machinery, as well as scientific findings. For example, the use and development and selection of high-yield cultivars or other aspects like the use of fertilizer and pesticides, as well as infrastructure development. Think about the irrigation infrastructure, irrigation that helps farmers to compensate for climatic or meteorological fluctuations in the water availability, which is one of the most limiting factors often in the production of food. How about food demand? Well, food demand, on the other side, is determined by the population and its consumption. So one key question to ask first is if food supply is currently sufficient to meet food demand. The answer is yes and no, in the sense that it's yes at the global scale and on average, and I would add in theory. But the answer is no, especially at the local scale, and more in detail at the people scale. This is because there are some different scale inhomogeneities, which can be well understood, introducing the role of international trade and the role of hunger and waste. That I will do it right away. This is talking about the global food trade, the international food trade. It can be observed that the spatial distribution of food demand, that is population, and the food supply, that is the places where the agricultural production occurs, do not match. So this displacement of these two factors requires the transfer of food from one country to another. And in fact, many countries can meet the demand for food of the local population only through food import, so using resources that are available abroad. In this sense, the global trade of food enables to overcome the limitations imposed by the local resources to the population growth, that is the local endowment, and feed more population thanks to the global dimension of food supply. Another type of dishomogeneity that can be observed also at the country level is given by hunger. No hunger is one of the development goals, the Sustainable Development Goals. This means that hunger is still present, and what maybe not everyone knows is that hunger is present in every country and in every place on Earth, not only in developing countries. And FAO has started monitoring the temporal evolution of hunger through the percentage of undernourished people and the number of undernourished people. And here you can see a time series of these two variables where the green identifies the gray line identifies the prevalence of undernourishment that has been stable after a market decrease, stabilized in the recent years. But the problem is that the number of undernourished people after an initial decrease started increasing in the last 3 years. Stabilizing around 800 million people in the world. So it's a critical situation. And these undernourished people are found everywhere in every country in different percentages, of course. On the other hand, so this homogeneity within countries is balanced in a way by the food waste. The food waste is a hot topic because it should be noticed that not all produced food is consumed. There are food losses occurring from the production phase to the retailer, and waste that occur from retailer to the consumer phase that sum to 1/3 of food production. So the amount of food that is dissipated, that is simply not used, is huge. It can be observed that industrialized countries and developing countries dissipate almost an equal quantity of food, but they differ in the ratio of losses versus waste. But the point is that if we could, in principle, collect and avoid all this food waste and loss, we could feed 2 billion people. So more than the number of undernourished people. So the answer to the initial question, is there enough food for everyone? In principle, yes. The point is that it's currently not available at the place where it is needed, or simply it's wasted, is thrown away as waste for the many different reasons. So which are the future challenges for food production? Well, will there be enough food supply to meet the future food demand? Well, addressing this question requires to observe the two sides of the same medal. The food demand is challenged by increasing population, increasing food intake. People tend to eat more and more calories, but also they are changing their diets, shifting from more vegetable-based or crop-based diet towards a more meat-intensive diet. On the other side, there is a challenge to food supply provided by climate change, but also by biotic threats such as pests and other problem of large scale like this one, and above all, the need for sustainability. I have mentioned the diets. I want to give a brief focus about that because maybe it's not clear to everyone that diets in terms of food composition and quantity have different environmental impacts depending on the quantity and quality of food. They have an impact on the agricultural sectors. They have an impact on resources, land use, water use, etc. They have a strong impact on emission, greenhouse gas emission and CO2 and methane emission above all. So we have to remember, and it's good for us to remember as customers, that our consumer choice have an environmental impact in all this aspect. And in particular, there is a huge difference between the impact of crop-based product and animal-based product. This is because the meat, for example, the meat has a long supply chain that includes all the resources that are necessary to produce it, starting from the breeding of the animal and the growth of the food that is provided as feed. And such long supply chain has inevitably a large impact. In the picture, you can see, in the infographic, you can see the different bars which highlight, for example, the amount of water that is necessary to produce the daily food intake that is characteristic for a citizen of the European Union, corresponding to different diets. The one to the left is the reference or current diet. The second bar corresponds to a healthy diet, so a lower contribution by animal-based products. Then we have the vegetarian, so no animal-based product at all. And you can see that there is a great difference between the first bar and the third one. We have almost halved the amount of water required for the production of the food needed with that type of diet. The other challenge for food demand lies in the future trends. There is a very recent paper provided by a colleague that is projecting into the future the population, the food demand, the trade, and the dietary composition. It's a very nice study that make this projection depending on different scenarios, like the baseline scenario, the economic optimism scenario, and other types of scenarios. And you can see the range of variables. And in particular, if you want to focus on the curve corresponding to the domestic demand, you can see that the only curve that do not imply a monotonical increasing in the food demand is the sustainable development. So we have all worked towards a sustainable development in order to limit the resources that will be needed in the future. In the meanwhile, we also have to face food supply challenges. For example, improving efficiency in crop production, for example, selection of cultivars, biotechnologies, crop defense and enhancement through pesticides and fertilizers. And also we have to take into account the fact that climate change will affect agricultural yield, negatively affect. There is a lot of debate about that because the ranges of such negative effect are not clear, but most studies agree in expecting a negative effect on agricultural yield because of mostly because of higher water stress. Still, by the point of view of the food supply chain, we could use larger areas. Where are we going to find larger areas? Are we going to take out forests? Are we going to grow food vertically, for example, like in this pilot project of engineered building where the cultivations are rotated in order to receive the necessary amount of energy and nutrients? Well, these are engineering answer to the challenge of providing sustainable food to everyone. Are we going to grow food in the desert? Well, it is already being done. Here you can see cultivation of potatoes in Algeria, in the Sahara Desert, where the water for irrigation is taken up from groundwater and is distributed through pivot irrigation. Are we going to grow food in the Arctic, maybe? Well, it can be done. There are studies focusing on the Arctic farming, on the possibility to build local greenhouses where crops are grown with a hydroponic strategy. And this system, completely engineered systems, may provide local food to population that live very far north, which otherwise will have to find food elsewhere and import it from elsewhere, with great impact on many aspects of technology and life. Are we going to grow food on floating greenhouse like this one? This is a pilot project at the University of Florence, hydroponic cultivation. This floating greenhouse promised to be extremely sustainable. There is no need for external energy because it uses sun rays, no land use, no need to supply water because it's taken up and treated from the canal where it is located. And this will guarantee the crop production for a few families. So this is another solution where we as engineers, we can work and try to contribute to a better future. Talking about water, yes, I'm in a good time. Talking about water, in particular, water availability, well, this has long been studied. It's certainly, by my point of view, also an extremely interesting aspect of science and nature. Certainly, hydrological cycles will strongly be affected by climate change. Even now, there are observations. What happens? Even now, sorry, I got lost because it runs alone. Even now, there are many fluctuations occurring in the availability of fresh water around the globe, which have different motivations, some related to an initial stage of climate change, some driven by human needs, and some simply driven by natural variability. Not everything is climate change, certainly. By the point of view of water demand, we have to stress one fact, and the fact that the water use that is associated to the personal need or the direct use of water for hygienic, for drinking purposes, hygienic purposes, civil and industrialized purposes, is only a small share, a small fraction of the total water that we use, that we need. We can see in the picture the 1 meter cubes per person per year is drinking. The red fraction is for domestic, but the blue fraction is for food production. So in reality, our largest appropriation of water resources lies in the production of food. In order to study this aspect, an indicator has been proposed in the recent past, is the water footprint that identifies the direct and indirect use of fresh water that is associated to the production of a good. But then the same water footprint can be associated or calculated for a consumer, summing up the water footprints of all the products that are being consumed. And this provides a lot of interesting considerations and conclusions. The footprint is separated into by colors: in green water, that is precipitation; blue water, withdrawals; or gray water in terms of pollution. But these are side aspects. A few general considerations. The water footprint of production, of global agricultural production, is 9,000 kilometers cubed per year, considering green and blue water. And only blue water is the 11%, so a large fraction. It's around 1,000 kilometer cubes per year. And the per capita water footprint of consumption, so we as an average human being consuming food and thus water, we have a per capita consumption of 4,000 liters per person per day. Remember that we have introduced the role of trade in meeting the places of production and the places of consumption of food. Well, associated to the trade of food, there is a virtual trade of water, also called virtual water trade, that connects different parts of the world, enabling the satisfaction of human needs in terms of food and water. Virtual water trade can provide interesting insights. I am just proposing one that is a study associated to the South to North Water Diversion Project in China. It's a huge project by the point of view of engineering and many other aspects. It's a project that takes physical water from the south and bring it to the arid north. Historically, the south of China was the producing place, was the bread basket. But then the population density, the increase in living standard, and the national policy about self-sufficiency pushed the country to move the bread basket area towards the north, which, however, lacks of water. How can this be done? Diverting water from south to north. A large volume is then transferred from the water-rich south to the water-poor north, with a huge infrastructure and a huge cost. The cost is about $50 billion. The critical aspect of this is that now the arid north of China, receiving water from the south, is growing the food that is then shipped or traded towards the south of China, where most of the population lives. And the important point is that the north of China exports virtually more water than what it gets from the south, from the water diversion project. So this is a criticality that highlights the fact that water scarcity in the north is being arsened by the project, not helped by the project itself. And this is analysis that was enabled by the water footprint concept and the virtual water trade one. So by the point of view of water, the future challenges are certainly those related to the food demand. Also, there are specific challenges related to the increasing of efficiency, so the possibility of obtaining more crop per drop. On the other side, we have all the challenges related to water availability, most of them related to climate change, but also related to infrastructure and sustainability. We know that climate change will have a puzzled and scattered effect on the water resources worldwide, but certainly there are conditions and situations and practices that needs to be carefully assessed in terms of their impact on the environment. This is one of the most important environmental crises that have been occurring in the recent past, which I suppose most of you know, is the Aral Lake. These are the pictures of the Aral Lake taken in the last 20 years, last 30 years, that document how the lake has been quickly shrinking until almost disappearing. And this was due to the irrigation infrastructure that withdraw water from the rivers inflowing into the lake, and such water withdrawals didn't allow the water to reach the lake anymore, which have been drying out dramatically. In order to assess sustainability, as engineers, we can develop indicators. One indicator, there are many indicators for many aspects. The smarter an indicator is, the more insight it provides into critical aspects. One is the water depth indicator that we worked on with Marta Toninetti, the same author as the future projections, where we compare the water footprint of production and the water resources renewability, which highlighted that there are some places on Earth where groundwater resources are exploited at a non-sustainable rate. So there are different strategies to cope with the future challenges related to water. We can use non-conventional water resources. We can use wastewater in agriculture, or reclaim waste or reclaim water, like the campaign of Singapore from toilet to tap, or the desalination of seawater, finding new water for our needs. On the other hand, we can act through water management, so introducing and studying integrated and efficient management of resources, and follow multidisciplinary approaches to understand the problems and to find solutions. There is a lot of research ongoing at the Politecnico. One of the projects is the Quasi project led by Professor Laio, who has just presented, which provide a lot of analysis and interesting results, beside a website that is very rich on data at the global scale, at the product level, by different years. Now, briefly, a mention about the energy problem. Availability and demand of energy, they are currently in equilibrium, and at least by the point of view of electric energy, because electric grid needs to be in equilibrium. The contribution of renewable resources is quite small if we consider the total energy consumption is only renewable, sum up only to a 10%. But if we consider the electricity production in the specific, the renewable energy takes a larger share, more than double, it's 22%. The future challenges are, of course, increasing the efficiency and reducing the demand, and finding new ways to exploit sustainably the renewable energies. Just a couple of mention here about criticalities emerging, where in the concept of competition between food and energy, where since land is a limited resource, shall we use it for agriculture to grow crops or for energy production, like in the solar field that is shown in the picture? And even if land is used for agriculture, shall we use it to grow food crops or energy crops, like biofuels? Here in the picture is a rapeseed field that is going to contribute to the biofuel production in the central France. So we often have to take into account the nexus problem, the connection between the water resource, the food resource, and the energy resource. Possibly trying to find multidisciplinary approaches and win-win solution. Is the one presented in the picture a win-win solution? Well, there is a provision of energy through the solar panel. We have the animals grazing in the shade, so more happily than in the sunshine, and therefore making more sustainable the food production, so the growth of the animal and then feed. But certainly we have to consider the nexus in the context of climate change, of the environmental impacts, and of the policy and government. We need to develop science-based strategies, and above all, we have to adapt to a changing system and trying to capture the opportunities that are provided and become available in a changing condition. Thank you for taking a little bit more of your time, but if you are students and you are considering to enroll in our program in environmental engineering, I will see you in PoliTo. Thank you.
Thanks a lot, Stefania. I think we just have a flash presentation by Valentina on the opportunities for environmental engineers. Please, Valentina.
Good evening, everyone, and I'm Valentina Socco. I chair the Education Board of Environmental Engineering degree and master degrees. And well, the decision to start this webinar series was exactly based on the core of our education programs. We wanted to outline the fact that becoming an environmental engineer means dealing with the grand challenges of humanities apart from being an engineer. And the topics that Stefania outlined are present in our programs in the various tracks that we have. We have a tracking climate change, where obviously these aspects are of great importance, but also in more industry-oriented or civil protection-oriented tracks, which are all related to the scarcity and the fragility of resources and land. So in these days we have the open days, and we have presented our program into webinars and chat with the students. So for those of you who are interested in our program, my suggestion is that you, apart from continuing following this webinar series, you check our website, you check the Open Days website to see when and where you can find us. And if you have questions also now about them, I'm glad to answer. And consider also that if you are a future student and you want to see how a virtual classroom of Politecnico is, to see what is the environment of teaching in the COVID emergency time, we have a chat open every Wednesday afternoon in a virtual classroom of Politecnico to chat with potential new student or new enrolled students. I don't want to steal more time to the floor, so for any questions about our education program, I will be glad to answer.
Thanks a lot, Valentina. We have some questions for Stefania. The first is from Alessandro Zurlo, and he's asking if we are going to face a major change in the food and virtual water network in the next few months due to pandemic, coronavirus pandemic. What do you think, Stefania?
Well, I think that it's a difficult question in the sense that a quantitative answer would imply the availability of data that is not common, because we usually work with annual data which becomes available a couple of years after the occurrence. But I can just assume that any change in the global trade of food has implication on the environment, and in particular on the virtual water network. Any type of change, not only China that is stockpiling soybeans and corn, but I suppose that in the case of a crisis like the one that we are observing in these days, the food trade will be negatively affected, and in general the model of the virtual water trade network will change, and all the countries will be affected. The problem is precisely this one, is the fact that since all the countries in the world are connected through food trade, in the moment in which, for any reason, the food trade should decrease, if not stop at all, because it's not realistic to assume that the trade will stop, but certainly a decrease could be observed, then all the countries will be affected by this. And more than others will be countries which are dependent on external water or food resources. So net importing countries are those which will be suffering more by any change occurring in the food trade.
Thank you, Stefania. Second question from Enrico Lucca. He's asking if is it technically and economically more difficult to reduce food waste through the supply chain, but not only through that, or to increase agricultural production in order to meet future food demand?
Well, this is a tough question, technically and economically difficult. Well, first of all, we have to highlight the fact that food waste occurs throughout the whole food supply chain, so in sense of losses and waste. Certainly reducing waste, that is the fraction of loss that occurs at the consumer level, is important and is a point where the policy should focus on. The policy and also the consumer concern should focus on. As for reducing losses, well, this will certainly be more difficult because part of the losses are structural in the way in which agriculture is performed and the diversity of places and ways in which agriculture is held.
Next question from Alessandro Battaglia is about precision farming and the role that Earth observation might have on the optimization of the energy food nexus.
Yes, certainly remote sensing is a fascinating field because it provides a lot of information about the current state of resources and resource use. There is a lot of ongoing work, and in particular, there is an optimization of the information that is being provided to the final user or intermediate user also. What remains, in my opinion, an important point is to validate these results, because what remote sensing or satellite, if we want, sees is one type of information that needs to be correlated with data in the field or physically measured variables. So provided that a good calibration can be provided in many different settings and contexts and conditions, then remote sensing can really be a paradigm shift in many aspects related to food production and optimization of resources use.
So, thanks a lot for participating, and that's all. See you next week. Bye bye.
Okay, see you. Bye bye.
Bye.
Bye bye.